floor is yours.
Okay, thank you very much, everyone, for attending today. Thank you very much to the other projects for participating. I'm going to make a short introduction about our project, CEEGS, Novel Carbon Dioxide-Based Electrothermal Energy and Geological Storage System. So, what is the CEEGS project? Well, it's a 3-year Horizon Europe funded project. It combines renewable energy storage. The CCUS concept is basically an energy storage system based on integrating CO2 in a closed loop underground, allowing first using the captured CO2 to be integrated in the surface, and then using in a closed loop for energy storage based on renewables. Besides, it has some additional benefits depending on the characteristics of the underground regarding partial sequestration of the CO2 in the geological formations, and depending on the characteristics of the underground, additional geothermal heat extraction. Our main objective is to provide scientific proof of the technology's techno-economic feasibility. It's an early stage technology, and we are advancing from a very low technology readiness level to also a low technology readiness level from 2 to 4. What is our technical approach? Well, we are storing energy using mechanical work and thermal heat and cold forms. We inject CO2 underground, compressing, and in the closed loop, we are having a heat exchange in a cold sink and a heat sink that delivers and supply in the charge and discharge processes energy, thermal energy, to complement the cycle. Part of the injected CO2 will migrate laterally from the production wells and will be immobilized by residual trapping. Why using CO2 instead of as a working fluid, instead of air or instead of steam, like other approaches? Well, it has some advantages. The first one related to the improved working fluid properties regarding pressure and temperature ranges for the specific application, the potential capacity of the geological lateral migration. It depends on the characteristics of the surface, and it will evolve with the time. Sure. It has relatively few geological constraints. Also, it can use thermal siphon effects, and also allows enhanced geothermal heat extraction. In the preliminary analysis that we performed, we have demonstrated already at this stage of the project that we can reach round trip efficiencies depending on the characteristics of the integration. These round trip efficiencies can be in the range between 40 and 60%, even higher. And the concept is conceived to operate with carbon dioxide capture from stationary sources as a fluid working fluid. So the concept has two stages. The first one is to fill the underground reservoir, so a period in which we are injecting CO2 and making increasing the pressure until the desired pressure, a nominal rated pressure, and then the oscillating operation around this nominal pressure within the mechanical limits allowed, more or less 10% of the nominal pressure. So it also has the benefit that because of this, we have this mechanical energy storage, but also we have this heat exchange in the as hot and cold, and we have the potential integration of the concept at moderate temperatures, let's say 150 Celsius degrees in the hot tanks, around 0 Celsius degrees in the low temperature tanks. So they are very interesting temperatures for being integrated into generation systems, district heating and cooling, and with different industries to use this additional heat. So what we try is to provide a scientific proof of the technological feasibility of the transcritical carbon dioxide cycle with the geological storage for renewable electricity. Who we are? Well, we are partners from 5 different countries, plus 20 affiliated entities linked to EFG. So we have a wide presence in whole Europe. What we are doing? So we are developing the concept of a novel integrated thermoelectric energy storage based on reversible transcritical CO2 cycles for renewable energy, and we are using both electricity and thermal and CO2 storage in geological formation. Why to do it? Well, it's an scalable system with capacities from a few megawatts to hundreds of megawatts. It's a seasonal energy storage concept, and it can be used for electricity storage and production, heating and cooling, for additional partial CO2 sequestration. The benefit compared to other technologies. So it has a huge scale potential because the application in multiple locations around worldwide, and also with potential of scale of the different scales makes of high interest for integrating within different processes. It's important also here to highlight that to this stage of the project, we have already identified that the requirements are not so strict as those related for permanent carbon capture and sequestration, and that there are plenty of potential applications or allocations in Europe and all around the world. So it's of high interest. And it allows also, compared to only surface energy storage system, a higher, a bigger capacity, energy storage capacity, because using the underground. So we have identified real synergies of integrating existing surface approaches for energy storage and underground approaches for energy storage. What we have been doing in this period? Well, we have been developing a proof of concept based on the integration of models for the systems, components, and their integration. We have developed a laboratory demonstration of 20 kilowatt thermal power, and also using existing data from previous projects. With this said, we have been analyzing challenges, barriers, and potential ways of solving the integration. So we have obtained very promising results, very interesting results regarding the ramp-rate efficiencies, regarding the expected levelized cost of electricity and capacities for energy storage. What are the challenges that we have addressed in this project? So The first one is integration of surface and subsurface components to a system. So the surface components are well known, the underground components are well known, but the interface, how integrated, is completely novel because we are considering in the second phase, in the charge discharge of energy storage, in operating in a closed loop, we are having completely different times compared to carbon capture and sequestration, and we have very extremely short compared to that, and we have oscillating pressures, and we have streams with particles, chemicals, so there are specific challenges related to that. So we have the first challenge, so integration of the surface and subsurface components assistant. The second challenge, the conceptual design of novel components adapted to the requirements. It's at early stage technology, so we are not making the final designs, but we have demonstrated that there are feasible designs regarding heat exchangers, regarding different components systems. The third challenge is related to the economic feasibility, where we have studied at the different impact, we have studied the life cycles. And we have made life cycle analysis, technical impact, and also very important, all the part related to the key dimension assessing key dimensions in the social acceptability that allows this early stage approach. We are almost finishing. We are here. So let me tell you that at this stage, all the challenges, all the risks that have been identified has been adequately addressed. So the technology that looks very promising at the beginning of the project still looks very promising at this stage. So there are solutions for the identified issues. There is a clear applicability regarding technology. For instance, now we are already looking for new projects, new proposals in which to pass to higher DRS. Let's see what happens. That's all from my side. Thank you.
Well, thank you, Ricardo. Let me turn on my camera. Thank you, Ricardo. That was really informative, especially for those that are not involved in CEEGS. And I would stop for questions because we will have the discussion later on. And I would immediately continue now to another project that we've invited to this workshop, and that is Pilot Strategy. And the coordinator of the project is Isaline Gravot. And Isaline, if you're ready, you can give us the presentation on the Pilot Strategy project. Please, the floor is yours.
Thank you, Marco, for the invitation to present. I will share my screen. So good morning. Hello, everybody. I'm Isaline Gravot from the French Geological Survey, BRGM, and I'm coordinating the Pilot Strategy project, which is a Horizon 2020 project focusing on the characterization of storage reservoirs for CO2 storage pilots in Europe. This is a project that is that started in May 21. So we already have 4 years of project, and it will be finished in 1 year. So it's a 5-year project. So we are arriving to the final year of our work. In this project, we are working, studying 5 different regions in parallel. So we have the Lusitanian Basin in Portugal, the Ebro Basin in Spain, the Paris Basin in France, Upper Silesia, so in south of Poland, and West Macedonia in Greece. So we have partners from all over these 5 countries, but also from Germany and from the UK for also supporting us. So in total, we have 16 partners on a budget of 10 million. So you have here all the partners involved in this project. So I will not list everyone, but as I see, there is a third increase that is also involved in your project. And CIEMAT is working also in the pilot strategy project in Spain. So the objective of this project is to provide a detailed study of saline aquifers. So we really focus on saline aquifers, not depleted hydrocarbon fields, with so the storage complex with the seal also, with the objective to propose some pilots for CO2 storage. So in Europe, focusing on Southern Europe and Eastern Europe, as a lot of things is already ongoing around the North Sea. So our idea was to go in other regions in order to foster CO2 storage development. And we are looking at all parameters that could be necessary for CO2 storage. So of course, also geological characterization, but also technical parameters, as well as social, legal and economical aspects. So we are really working, looking at all these different aspects that are very important in developing CO2 storage, not only geology, but also risk assessment, social acceptance. We want to propose a complete study for pilots. So this project includes all this aspect for CCS, and we are developed in different work packages. So work package 1 is coordination, but we had work package 2 about geocharacterization of the storages, different reservoirs, work package 3 simulation, work package 4 the pilot development, and work package 5 all the safety aspects, work package 6 an entire work package dedicated to social acceptance, and of course all communication and impacts of the project. So we are working on this workflow in all the regions. So especially in the French, Spanish, and Portugal regions. In Poland also, almost all the steps are also covered. And in Greece, they are less advanced on the knowledge of the reservoirs. So they are doing mainly the first steps of the workflow. But the idea is to work in parallel and to have this assessment done in each of the region. So the main workflow was subsurface data acquisition with working on a sedimentological description of the aquifers and the petrophysical measurements also. Working also on seismic data available. And in France, we had a dedicated seismic acquisition performed at the beginning of the project. And then development of a static model for the reservoir complex. And based on this, developing dynamic simulations with CO2 injection in order to predict the reservoir behavior during the injection, and also on the long term, during 1,000 years, the evolution of the CO2 plumes, the pressures, and so on. At the end, in order to optimize the well location for building a pilot, making some evaluations of different scenarios and environmental and economic assessment of our pilot concept. And in parallel with all these tasks, of course, assessment of the risks that could be linked with the CO2 storage. And as I said, we have a dedicated work package to social acceptance. So all along this technical workflow, we also have set up exchanges with groups of stakeholders, local stakeholders, regional, national, in order to install a discussion at all stages of the project. So we are here just starting the final year. Just for job characterization part, I've give the example of the Paris Basin as its case I better know. But yeah, this kind of approach is followed in each of the region. So in the Paris Basin, contrary to the other regions in the project, we are studying an aquifer. So it's a Dogger reservoir in the Paris Basin, which is the Paris Basin is a sedimentary basin in the northern part of France. So it's almost a quarter or a third of France. So we have this huge basin, and we are studying this area not far from Paris, and we are studying the Dogger aquifer, which is in middle blue here, located at 1,900 meter depth at this in this studied area. So it's carbonate reservoirs, and we have been working on building a geological model of this studied area. So this is this square in green. But we have taken into account all data that could be available also in the surrounding area in red here, working on well-logged data, cores that have been that are available, thin sections, and some plugs. And also, as I said, we carried out a 3D seismic acquisition in this area. So we worked on a 10 kilometer by 10 kilometer distance. And this is some pictures we had from the seismic campaign. Here is the location of the sensor that has been deployed in the area. So not all proprietaries from all this. It's a very agricultural area, and not all field owners gave the authorization to deploy some sensors. So in some areas there are some holes, but the company performing the seismic acquisition managed to get good data of the underground, and this is the seismic cube that was obtained. And also during this activity, we already started having some exchanges with local population, and especially some public authorities in order to do this campaign. All the data that has been acquired was aimed to build a static model in order to perform the necessary simulations to study the injection of CO2 in this reservoir and the long-term evaluation. So we followed this general workflow to build the model. So starting from grid construction with seismic and well markers, interpretation of well data, populating the different layers with petrophysical data, and also taking into account the uncertainties of all this data and trying to upscale. And very quickly after having built this dynamic models, we have also performed optimization in order to define what would be the best location for the injection well in our in our pilots. So taking into account a lot of factors such as CO2 storage capacities, but also, for example, geomechanical and geochemical impact, distance to existing legacy wells in our regions, because we have some, it could be some leakage pathways, and also distance to faults, if there are some, distance to the potential source of CO2 emission. So we try to minimize this distance. Also taking into account some criteria at the surface that could also be an exclusion for drilling a well there. This is work performed by our colleagues in Portugal. So they made some optimization, testing different places for CO2 injection in their studied area. So in red here, you have some existing faults, and in white here, legacy wells. So the idea was to try to maximize the capacity injection of CO2, but also minimize the risk of the plume reaching the legacy well or the surrounding faults. So this was the same work in France. So we had different criteria, also trying to be far from existing wells in red here, and we had different zones that could be good storage sites for CO2. As I said, also we had a dedicated work package about social acceptance. At the beginning of the project in 2022, we had a survey of the local population in the different regions. So we have also in Portugal, at the beginning of the project, there were two potential storage sites that were on the table. So one onshore, one offshore for each. And after 1 year and a half of projects, they made a decision to go to the offshore one for Portugal and to the onshore site for Spain. So at the beginning of the project, survey in the local population was done for all the sites. We had the very, very different rates of, for example, here we show the local acceptance of CCS in these different regions. So we had very different results depending on what region was studied. And especially in the same country, we had different also results depending on the case that was proposed onshore, for example, or offshore. In Spain, in fact, in Spain, there was a slightly higher acceptance of the project for onshore storage rather than offshore. That is one of the reasons why the Spanish team chose to go for the onshore site. In Portugal, there was also different perception depending also on the offshore or onshore site. In France, we had surprisingly higher results, higher acceptance that in other countries. So we were very surprised because in France, we are usually very not population is not very happy when we speak about doing something in the ground. So we were surprised. But we will have a second survey this year in these three regions that are studying in more detail. So we will be able to compare the results with the beginning of the project. Also, what we have done in this project is setting up some committees of regional stakeholders. The objective is to involve some people representing the affected communities by CO2 storage in order to have to allow them to communicate their views and their concerns and their needs because maybe their concerns is not what we, as engineers or researchers, we could have thought about. So sometimes they care about different things than we expected. And also the idea is to share with them the progress of our project. At the beginning also we made a lot of pedagogical presentations in order to explain what is on the ground, what is a reservoir, and so on. And the idea is to also to involve them and to work together to build a CCS pilot concept that would fit with local reality, and also to enable them to work as informant in the region about the project and about CCS in general. And that's it from my side. And if you have questions, do not hesitate to contact me. And we have a website, pilotstrategy.eu, where we publish all the reports we are issuing. So if you want more details about these geological things I presented, please also jump into these reports. And we also made some webinars for each region, if you are interested in one of them, that you can access also on the website.
Many thanks, Isaline. That was really an interesting presentation, and I see you have some interesting feedback also from the acceptance, the public acceptance of such technologies, which I would bet you it's of interest of all of us that are involved in similar projects, because this is the challenge that I would think it's the highest. We can deal with technological ones, but because they are predictable, while with the social ones, they are quite irrational, I would say. So thanks again. I leave now your questions for the discussion, and I open the floor for additional presentations. I know that we've invite quite a lot of projects. Unfortunately, due to the short response time, many of them could not make it, but they are quite interested in the future cooperation. But I'm just asking whether we have any additional participant here at the workshop that might want to have the interest to present some of their work, even if it's not Horizon Europe project. We would still be very glad to hear about your experience in CCUS. And if not, well, let me pause here. Maybe we have somebody. So we don't. Okay. Then I would suggest that if we have any of optional partners presentations that could also jump in, that's not only, as I mentioned, the project, but also our partners within CEEGS with maybe some interesting insights in addition to what was already said. I'm going to stop for a couple of seconds to let you think about it and decide. Okay. If not, then I would open the floor for the discussion. We heard two quite interesting presentations on two projects, on pilot system and CEEGS project, and now the discussion is open. So I ask you to raise questions, either to, of course, to Ricardo or to Isaline. Please.
Yeah, this is Gerhard here.
Hello, Gerhard. Please.
Yes, I just want to add one question to your survey on acceptance. How was this organized? Is it really representative, or can you just give some information on that?
Gerhard, that was for Isaline, right?
Yes, of course, yeah.
Okay, so please
so.
specify so we know.
The question, it was online survey. So, and the company doing this survey was is a dedicated company that have the experience in doing some representative panel, but it's still online. Sorry, I forgot the word. So I guess that it's representative from people that attend to online things. So
Yeah, but this survey is somehow biased, huh? If it's like that.
Yeah, that is.
Unfortunately, yeah.
I think that's why some acceptance rate is higher than what we would have thought. But we also working on the local scale with the stakeholders I spoke about, and these are rather older people that have time to attend this kind of meeting during the work days, and they are they have some. They are participating to these discussions, but they're not really keen on these projects. They ask a lot of questions, and they even have some local associations of environmental protection of the environment, and they are rather even against this kind of project. So we have a lot of different reactions.
Yeah. Okay, I understand, but this, knowing this, it might be like that. As I said before, the survey is not really representative, and I think we all have this problem. How can we really catch up the public opinion?
Yes, that's why for this second round of survey, the question was because also the stakeholders we are speaking about, we shared these results with them, and they say, okay, maybe it's not also very representative. So we heard this remark already, and we said that we try for the second round to open this survey to the most broader population as possible. But still the question would be if it's representative, if this survey is shared by this local association I spoke about. Maybe they would share to all their friends that are not
exactly.
that are against the project. So maybe it will not be representative as well. So we have a lot of discussions about this, how to do. And also we want to be able to compare the first round and the second one. So we have to use also the same methodology. So it's still a big question.
Yeah, thank you.
Well, thanks. Like we already mentioned, it is quite a challenge, this public engagement and social acceptance. Ricardo, sorry I cut you in. Please, you had a question or a comment.
Just also to contribute to the discussion related to that. In our case, for instance, the part of social acceptability was hard to define because we still haven't specific locations where to ask to the people. So that in our case, it was internally there was a lot of discussion and analysis how to perform it. The experts on social acceptability finally decided to go on three focus groups, that each one in two different sessions, and the composition of the people in these sessions were, let's say, was search for ordinary people, let's say not scientists, not politicians, not people with a specific involvement in environmental issues, or try to be as ordinary citizens as much as possible. And in the first round, the first session, it was presented by the concept, the pros and cons, and global, and they make a specific news related to that in order to give an overview to people that are not experts with technology. And also they have the support of an expert in each one of the countries, an expert of the project supporting for the questions that can be raised. And after that, there was a second session trying to see how, after thinking of the different things that has been dealt, how was the perception about the technology. It's very hard. It's very hard to see if with a reduced number of people, how representative they are about it. And it's probably, as Marco has said before, it's one of the, no, I would say the most, the bigger challenge, or one of the most relevant challenges, because, for instance, in our case in CEEGS, that we are first injecting and then going in a closed loop, it looks that the technical parts can be more or less solved. The better performance, or it depends on the solution adapted. But the perception of the people, it's can completely move any technological solution.
Thanks, Ricardo. What I can sort of summarize from all this is that since we are, most of us, technology-based or natural science-based experts, we should always include the social sciences within such activities in projects, and also then in the real case projects, in the real case scenarios, because people are sensible, and it's logical that they are, based on some of the bad experience from the past. And also people on general have fears of new things. So we need to show them how such a technology can actually help us live in the way we are living today, also in the future, because we have so many challenges that we have to deal with. And of course, we need to involve them from the very first step. Like they say, first foot on the ground, you already have to have a social scientist with you that knows how to translate your complex language into an ordinary one that general public understands. Before I give the floor to the next question, I would kindly ask you, I sort of forgotten, and I do apologize for that. Could you just give us your feedback on the questionnaire that it appears on your screen, just to see from which sector you're coming from? Because that's also some statistics and information for us that is useful, so we see what the interest is. Of course, it's, again, like Gerhard has mentioned, it's a bit biased because it was distributed within the channels that we all know and we have. Anyhow, please do fill the questionnaire so we have your feedback. Thanks.
If I may
Okay.
add something, Marco, related to the previous
Please, Ricardo.
discussion, one thing that it happens at the beginning of our project is that we have we are experts in different areas, so mechanical engineering, power systems, geological, different areas, and at the very beginning we had very different languages. So in the meetings we talk, for instance, for the social pass side, we talk they say something and we understood something different, and we try to discuss or to contribute in things that after a period we identified that we were not talking of the same language. It's very important to have experts in the specific areas. Let's say the social part is the specific. They have a specific language and specific approaches, and are completely different to see things that for non-experts like me can be to other, let's say, dissemination or things like that. It's very important to keep that in mind, because if don't, we can have some misunderstandings or not having the best results, the best results related to that.
That's why I would also say that having these difficult questions that Isaline has mentioned during the public discussions is actually good, because then you can see all the varieties of doubts and questions that appear in the society, and you can get prepared how to answer them properly the next time, or even the first time. It depends. But yeah, it is important to be scrutinized as early as possible, so you're prepared for the different scenarios in the future. Iselin, do you have anything to add to that?
Yes, I think it's very essential to have the social aspects are developed from the beginning of the project in each project. It's crucial, but it does not mean that your project will be accepted. It's just necessary, but not sufficient. And especially, but it's also the feedback we had in the French team working with these people that we have been involving them from the beginning, giving them also a lot of knowledge about the underground, so that they can make their own opinion about the project. And also they told us that they were, because us it's just a research project, so we are studying how to build a pilot, but we are not drilling a well ourselves, and we will not do a CO2 storage ourselves. So the objective is to prepare all the works, studies in order for storage operator to develop one pilot if they're interested. So also what local people told us, that thanks to us and thanks to us involving them in our research, they also get more information about CO2 storage, about their area, and they can also make their own opinion about one project that would arrive later. And so it's also an important role from us as geological surveyors, so to be kind of reference to how to say, they can have confidence in what we tell them about underground.
Well, thanks. You mentioned something that also Ricardo previously mentioned, the education of the general public to let them know what the technologies that we want to implement or test are really about. Because I think that many of the fears exist and start with ignorance, with not knowing what is behind it. And that helps.
It helps, but it's not because people understand that they will agree. And we have these people from this local association that are well, they are not geoscientists, but they are scientists in geography and other engineers, and they how to say, they made their research on what is CO2 storage and so on, and they are very well informed, but it's still they are against. So it's not true saying that if you educate people, then they will understand, then they will agree. But
I would say
it's necessary.
I would say it's necessary, because if you want to convince those that are definitely against, you have to educate them first. It doesn't, like you said, it doesn't mean that they will convert in a way, but at least it's a higher chance. If they don't have the information, they will never think of it in the potentially positive aspect. They can be just populistic, drawn by whoever takes the advantage of their ignorance. So it's a necessity, I would say, to educate. What are the suggestions or comments from the audience, from other participants? Do we have anybody? Gerhard, you have your microphone on, so
Yeah.
I expect you would
Yeah,
like
okay.
to add
I'm
something.
afraid I said this before in another meeting or so, but it's not only educating the society, but it's also educating politicians, because what we are seeing
Oh,
now,
yeah, yeah,
especially
yeah.
also here in Sweden, they name what scientists or experts are telling them. They just name it. It's your opinion. And this is very, very dangerous because they do not accept what you are telling them. They have met they have met people that have met much more influence on them, and they accepted their opinion or their meanings, but not what we may tell them. And this is really a problem nowadays. I would say. No, it's educating the society, but also educating politicians. And okay, not only you have to reach them. This is the problem. And of course, EFG also has made big efforts to go ahead in that.
Yeah, Gerhard, you're absolutely right. And you only have 4 years or even less to be successful, because then it's all over again. Any other comments or suggestions from the audience? I don't see any hands raised or any microphone
If I
on.
may, Marco, yeah,
Please,
just
Ricardo,
to
go.
change the subject regarding the social acceptance, also from the technical point of view. So, for instance, here in the CEEGS, we are having a period for captured CO2 is injected, and from a period, and then we start to make the pressure oscillation internal related to the charge and the charge for energy storage. One thing that it comes to that we need at the future for advancing to with the well at this stage, we have seen that technological solutions are feasible for the challenges that we have identified, and now we want to go to further projects, further proposals, and to be granted with that. And now we are breaking the approach in one hand, porous media, and in the other one in salt cavities, because we have identified different solutions for them and different needs for that. So, for instance, now in the project for future proposals, we are looking for available salt cavities at the scale of research projects, not here. So, and also for injection wells that could be used for higher TRLs. I don't know if someone already knows where the availability or someone is interested on participating, collaborating, or even knows someone who has the interest or the possibility. But it's not easy. It's not easy to go to higher TRLs when you have to deploy the technology, in this case with injection. I want to put that on the table on the room.
Well, thanks, Ricardo. This is an invitation and it's open to everybody. So if any of you have any suggestions or even proposals for the future cooperation, now is the time. And also, Iselin.
Or later, they can write.
Or later.
Absolutely.
Of course. Of course, if you're too shy to step forward now, you can always email us or contact us. No worries. No, I don't see any reaction. Obviously, people need a second coffee now. The lunch is approaching. Okay. What, in addition, I would say to this is a question for both of you. in addition to social challenges. I mentioned, and I didn't want it to be to diminish the importance of the technical challenges. What other bottlenecks or challenges do you see in CCUS in the future? Let's give the lady the first option to answer.
Policies and political support for CO2 storage. We really need. It really depends on the countries, but except in the Denmark, Norway, and UK, where we can feel that there is a political support. We in the other countries we really like this, and a stronger willingness from the authorities to develop, because they are also looking at the social aspects and saying, okay, but if people don't agree, so it's of course we have to take this into account, but it's kind of I don't know, hen and the egg, chicken and egg problem.
Chicken and egg. Do you think that this acceptance in the northern countries, or at least the three that you mentioned, comes from the fact that they already had some oil field explorations and exploitations in the past, especially Norway and UK? Do you think that's the legacy of that?
I think so. And also the fact that, not for Denmark, but other countries, it's rather offshore storages, so it's far from the ice, so maybe it's easier. In France, we are rather studying onshore storage capacities. We are very much more concerned with this, also linked with population living there.
Okay.
And so political support also that gives a kind of national guideline. We go there and it's good, and
yeah, we'll come back to politicians. Thanks, Zaline and Ricardo. What do you see? Which are the biggest challenges in the future?
Well, I agree that at the end it's the regulatory framework, an adequate regulatory framework, stable in the time, must be developed, and it depends on the politicians. And it's important to understand that the potential investments are huge, and the companies must feel confident on the stability in the whole processes from the very beginning that they start to make the investment, and from the period it was going to be under operation. So adequate regulatory frameworks is one of the big challenges, maybe the most, and it's also related to the social acceptability we have been talking before. Without social acceptability, we don't have confidence of have a stable regulation for a period of 20 years, 30 years, allowing to make adequate analysis on the investments and profitability of the companies at the end. This is one of the big challenges, for sure. And also, I would say that it's not only the final regulation, but also I would say also the regulation for going to intermediate steps, also for the development of the technologies. In our case, we see that we have to go directly to the condition of the final exploitation. So, of course, in research projects, even in huge research projects, it's very hard to go to the condition of final exploitation regarding the requirements of locations and all the normative that must be followed. So it's a penalty also on that side. And another, leaving apart the part of regulation, also I also see in our specific case for CEEGS and energy storage, salt cavities, that I was saying before. Also, there is a huge competition regarding different approaches for exploiting them. Hydrogen, that's for using for storing hydrogen, or in other cases. So it's not clear if we will have a room for reaching this potential resources for using them. It doesn't look the same for the porous media. There is not so clear a competition with other technologies under development, but still, but it's also another challenge that I identify. And finally, and also is related with the two previous comments, also the investment, the size of the investment. Huge investments are required to go ahead with CCUS, energy storage based on CCUS. So it means that companies must be completely convinced to invest there, because it's a risk for them to go in this huge investment. And it needs trust on the future, trust on how it's going to. So these are the three
Thanks,
challenges.
Ricardo. I think Isaline has raised her hand, so please, Isaline, you have a comment or question?
Yes. When Ricardo, you spoke about the regulatory framework, it reminded me that I was wondering in your concept, you said that CO2 would be a partial storage for CO2. Would this concept be considered as CO2 storage by the EU directive, or is there a need for changing the regulation in order to have this CO2 considered as stored, and how you can prove that this quantity of CO2 is stored? Because at the end, there is a need for certification of the quantity of CO2 that is removed from the atmosphere, and this is linked to maybe at the end to the economics of the concept. If CO2 emitters they can save some taxes because they have stored this CO2, then there can be a business model.
Yeah, well, in our case, we have two periods. A very graphic approach. First, we inflate the ball, and then we play with the ball. So in the first period, it's in some scenarios we are considering between 1 year and a half and 2 years injecting CO2, injecting CO2. And once that the operating pressure is reached, then we start to operate in closed loop. From time to time, when the pressure decreases because of the CO2 captured, some CO2 must be reinjected to set again the standard pressure set for the. So for sure, in the first period, it can be considered
stored.
stored.
Kind of cushion gas.
Yeah, so yes, kind of cushion gas. Yeah, but there is no regulatory framework, and we have identified how to deal it with the second part related to the energy storage. There is recent regulation related to energy storage concepts, but not in our case. So we would need to develop a specific one related to. It is possible. So to be honest, it's not. It depends on the say what there is a compressed air energy storage systems already operating for very long periods, and they are operating without issues. So it's something possible to be developed, but I was trying to define the word in English. Voluntad. It depends on the decision or the support.
You mean the willingness?
The willingness, yeah, sorry, yeah, willingness. Depends on the willingness to support it. But we haven't yet, and maybe having these regulatory frameworks makes everything a big abstract, or it is still on the research side.
Which gives us the time to actually prepare the potential support for the legislation. I mean, legislation is always post festum, right? It always responds to the real world challenges and scenarios. It's never in advance, because that it would be just hypothetical, and lawyers don't work like that. They are not paid for something that didn't happen yet. So I'm a bit nasty. I'm a bit nasty now, but that's how it is.
But anyhow, for instance, in our case, we have an energy storage system for renewables, large capacity, seasonal, with an impact in the underground, but not very small in the surface. So the impact for the citizen is lower than if they have the same thing in front of their houses. It's not the same that you have underground. You don't see it. It affects other things, but so, and one important thing that it comes related to the blackout that we have in Spain, it uses turbines, synchronous systems. It allows to maintain the stability of the grids. So it has things that can be of interest for the politician also. So
which is a very good argument, Ricardo, especially the blackout, the recent blackout in the.
It was not good for all of us, but anyhow, give us additional people hear us and more than before.
Well, thanks. Any other comments and or questions or contributions? No. So what I suggest, Isadine, that we might discuss potential synergies in the future. The way I understood is that your project is coming to an end, similar as CEEGS. I didn't mean that it's ending for sure, for per se, but just you probably already seek future opportunities to continue with where you sort of, I would say, finish within this project. And let's try to find some synergies and potential overlaps where we could cooperate in the future, because that's something that I guess is the point of all these clustering workshops, to find synergies and potential future cooperation and lift it to the higher level. Would you agree with that? I mean, you can just nod. You don't need to answer if you don't want to, but that's a sort of invitation
Sure,
from our
it's something
side.
we can think about. First, is that our project is, I think, is less research than yours, because the objective of at the end of the project is to prepare the kind of the studies that would be used by an operator to request for a permit, a storage permit. So at the end, it's very comment dire, say, practical results that could be used to effectively develop storage. So what would be the logical follow-up of this project is with working with operators to drill a well and do an injection test in order to validate the pilot reservoir. But this also we made a lot of work on these different areas, so that could be also interesting for maybe some case studies for your concept, because mainly these aquifers also could be, I think, may have some potential for geothermal, at least in the Paris Basin, that's for sure. Dogger Basin, the Dogger Aquifer is used in other places for the geothermal activities. And also our wish is to try to do the same as we did in these areas on other areas in Europe, with the same approach and workflow.
Basically, you're looking to do the full atlas catalog of potential sites for the future, which is helpful. I mean, this is something that we also try to, at least on a very general scale, assess in CEEGS to see the potential opportunities. But you're already step ahead, maybe with a little larger capacities, but still something that is useful also for this technology.
Mm-hmm.
And Ricardo, correct me if I.
Yes, no, I fully agree. So I see potentials, and so even in the conditions that we need, for instance, in the CGS, if it's developed for further steps, it's required studying different conditions to the one of CCUS. So because in our case, we will have charge and discharge cycles that short times compared to the geological ones. And the conditions that we are going to have, let's say that they require not so strict, not so high requirements conditions, compared to the permanent for ages of energy of CO2 captured. So it's different conditions can open studies to different approaches and there are, for instance, in some regions, some places that are better for hydrogen storage or CCUS can also be considered under underground energy storage based on CO2. So I see potentials for studies, but let's think, keep in contact, and we exchange emails and we see potentials. As I was saying before, for instance, we are now looking for salt cavities available or interested would be for further developments related to CGLs. Not only salt cavities, but we have divided the salt cavities with some characteristics, porous media for other characteristics.
Excellent. So that's I would say a good starting point, or one of the concluding steps and concluding points and following steps. I now, for the last time, ask anybody from the participants whether they have any questions that might have come up or any comments before we slowly close this workshop. I don't see anybody. Okay. Anyhow, if you agree, I would sort of wrap up and say that we've seen that all the projects the two projects that were presented, and also during the discussion, it unveiled that in addition to technological challenges, which we are quite successfully addressing, the additional one and quite important is the social aspect challenge, and not only for us, for all the environment-related activities. And we need to address that also with the same prudence and with the same attitude as the technical ones. And there's lots of improvement to be done in the future for all of us. And also, the technology is promising, and it's a viable solution for the future challenges of reducing CO2 footprint and also utilizing then CO2 for actually energy production. And we need to find a viable or interesting, let's say, joint idea for the future, and maybe we could then develop it even further. And with that, I give the two of you, if you want, some final words, and then we will conclude the workshop. And again, ladies first, if you want. Isaline, a couple of final words.
Well, thank you very much for the invitation, for presenting the project and exchanging about all these aspects that could be so we could find some interactions and potential for the end. So it would be, yes, it would be great. And yeah, thank you for your questions. And yeah, I was happy also to disseminate the work we are doing in this project.
Thank you very much. Ricardo, final words?
Thank you very much for the participation. Thank you. It has been a pleasure to meet you. So thank you all of the attendants for being here. Please contact us for any curiosity, any idea related to the CEEGS project, others, and it has been really a pleasure. Thank you very much.
Thank you. Thank you, Isaline, and thank you, Ricardo, for your presentations. And thanks to all the participants for joining us today at this clustering workshop. Let me just also inform you that every second Thursday at 10 o'clock, we have the online coffee chat. And that's really informal chat based on different topics regarding the CEEGS project and also, of course, related to carbon capture, utilization and storage. And the next one is in 2 days, actually. So you're kindly invited. Just look for us on the social media and you'll get the link for the coffee chat. It's a half an hour, really relaxed and really informal chat with your coffee, tea, or whatever you drink in the morning. So you're kindly invited. And with that, I conclude this workshop and thank you very much for your participation. And I wish you a successful remaining of the day and hope to see you on Thursday. Thank you very much.
Thank you.
Very
Goodbye.
much. Goodbye. Have a good day. Bye.
Bye.
Thank you.